our new topic from this week, which will take about 2 weeks. It is the one shown on the screen, deep basement construction. Week 5 this week. Basically, we're going to be talking about what we call it in the industry retention system, or they call it retaining walls system, right? There are, again, different naming about it. And yes, we will go through different types, challenges, why it's used, where it's used, and same thing what we did with the portal frames. And this one we're talking about today, it's going to be one of the key things you have to represent for your second assignment, which we will start talking about Wednesday. So yeah, retention system, the word retention really coming from the process. So basically this is the natural ground. Yeah, the red line here, it's the current ground. And if we need to make 3 stories, so this is the dirt, the ground level. And if we want to make a basement like 3-story car park, 3-story, like it goes to 10 meters into the ground, something like this. Okay. You can't go ahead and just cut it like this. What's going to happen? If you go and take your trucks or take your excavators and excavate it with the green line, what's going to happen to the soil? Can someone just tell me what he or she thinks?
The soil around will collapse in, maybe?
No, maybe, definitely. Yes, the soil will basically get disturbed and collapse. Now, there's going to be a soil report which will tell you how critical it is. If it was rock is kind of cohesive. It will be sticking to itself. However, you can't find a rock happening all the way 10 meters down from the ground. You always get, even if you have some floating rocks here, you may have some clay there or sand. So usually you got sand and fill in the top, so it's not stable. So what we do here, before we excavate, we have to build a retention system. That's where it's coming from. It's you want to retain the soil until you actually build your hole or your basement, and then start putting your slab, putting the columns, definitely footings, columns, the other slab, another column. That's really how it's working. This week and next week, this week we will talk about just the type of retention system we want to focus on. And we're going to talk about 3 main types which are widely used locally and again internationally. And there are other types, but the concept is same. There is like different concepts and different materials used, which they kind of think about the same considerations we are bringing in this subject. All right, so this week we will go carefully through 3 types of retention systems, and we will talk about a case study just to show you how such things are related. Right, now there is kind of recommended textbooks that we found help young engineers and students if they're really keen to get into these kind of construction components. This is one of them here. And also we're dealing with geotechnical, with soil properties. So you need to know more about high level of geotechnical inputs, which is kind of developed by Ben Development, and it's available online. It just gives you some good ideas and insights, and sometimes we look at such resources to answer some real questions we have in our jobs. But again, I can't tell you these 2 resources, they are just for your own library and additional learning. But what we present and discuss during the workshops and lectures are the one you should be aiming for your final exam. Right, so basement retention systems. Right, there are factors which one of you have already mentioned, one of you have already answered me about the first thing we worry about is the soil condition. So if we think about excavating a hole, 10 meters, even 3 meters basement, like most likely you're gonna have a 3 Bs. You gotta construct or look after 3. It's just a single car park basement. It's a 3 meters deep. Definitely you also need a retention system, which I will talk to you about. And our example, we start looking at the school, the senior school example, will give you a clear idea about how such things are documented. So there are a number of factors which impacts the retention system, or really determine how complicated building that retention system is. Soil and ground conditions. So the soil, we just talked about it, depends on the soil type. Is it cohesive? Is it loose, sandy soil? It is more problematic than clay, and clay is more problematic than rock, right? And that's what the soil report gonna tell you. The soil report gonna tell you if you have a basement like this. I'll go back to my picture. It will tell you you cannot leave the green line as shown here. You have to batter it backwards, so you have to slope it. You have to cut this line into a slope. Now the angle of the slope, it's up to the geotech engineer. If it's sand, it needs to be 45 degrees. It needs to be very safe like that. If it's clay, it can be maybe even 30 degrees, this angle here, right? You can have it steeper. If it's rock, sometimes they tell you 10 degrees or even 0, especially if you're excavating 3 meters basement only. Usually if you have a decent rock, it will be very stable. Don't worry about it. You can just excavate and then just put your wall without worrying. The big challenges, and that's what we're going to discuss and think about, is if you have a building next door. If you have a building next door and you want to excavate, now you have two troubles. It's not only about how stable is the soil, is what we're going to do about the neighbors, the next door property or building, which we will discuss. So the first factor here is soil. Second one is the groundwater. Yes, groundwater table yes. So usually in Melbourne, especially the southern eastern suburbs, the Melbourne level, ground level is lower than like kind of, I think the lowest areas around southeast Melbourne, like close to the CBD. And usually you got seasons where the water table gonna level up. So you got actually water underground, like a water table, they call it. The water raise up in some of the seasons, especially in a wet season. You've got a water table. And if you are constructing during such season, then there's going to be a trouble. You have to dewater it. You have to use even more expensive retention systems, because as much as you excavate, you're going to have the water coming into the excavation, and that will again not only bring water that you can pump out, it's also gonna bring all the sand particles and or clay, whatever other ground materials. So it is going to be a more complicated process, right? That's to do with the water table. What else we can talk about here? The height of the retaining wall. Obviously, whenever we go higher, there's going to be more expensive, more challenging, more time to build. Number 3, what do we want to achieve? Right? The deflection criteria. Do we need to have very stiff, strong retaining wall that does not really sag a lot? So again, this is my basement. If I drew, just usually we're going to show you how to put a retention system. You're going to be putting piles and concrete wall. Now, and there's going to be piles going more deep into the ground, even below the basement level. Now, when I was talking about the thickness of the wall and how big it is, it depends on how deep is the soil, is the basement or excavation. If it was only one level, 3 meters deep, then you may survive with 450 diameter piles. If you're going to go deeper, you can go up to 900 diameter piles. Okay, so and again, that's more complication, and you need more propping process. So if you excavate that much, you're going to need to prop it. Same thing what I discussed with you about assignment 1 for the portal frames. If you excavate and you did not build the first floor basement level yet, you need to prop it, maybe with 2 levels, at 2 levels. Then when you pour the first floor basement, you can't take this away. And when you build the second floor basement, you can't take the second one away. So here you've got level 1 basement, level 2 basement, level 3 basement, then ground floor. All right, so as we said, whenever you go even deeper, they're going to be another package for you to price for and allow for in terms of time, which is the propping. You need to think about how you're going to prop it as you go. And we will discuss these things in more depth over the lecture notes and also for your assignments as well. Well, so these are factors here, which again, you know, what I'm going through now can be an answer for your final exam question, can be an answer for your assignment question. Yeah, I'm giving you here ideas. Wall geometry. Yeah, sometimes the architect, usually, again, if you go to many shopping centers in the city, you will find they use piles. And between the piles, they have shotcrete walls, something like, let me show you, definitely, yeah, something like this. And we're going to be putting shotcrete wall between, something like that. So these are the piles I keep talking about. And between them, we're going to just put shotcrete. Now, this may look fine for a car park. The architects are not worried about the look, right? However, you can't have this in a habitable area. Maybe in a basement, you've got some shopping centers, or so that means you have to, if there is no room architecturally to build such big pile, 900 diameter pile, then the challenge will be we have to think about alternatives. Maybe we go with a solid wall, 200, 250 thick wall, all the way from this point to the end. Right. So again, sometimes you are limited architecturally with what the architect they want. If they have not enough room, then maybe 900 each side will cost a lot in terms of the availability of space. So in this case, it can be more challenging, depends on what's really desired. Design life, it's something related to the acceptable deflections. Now, usually in residential with car park, we don't have issues like what we're talking about the design life. It is, you know, concrete structures, they kind of sag over time. They kind of sway over time. Now, if you're building something, a retaining wall for a road, maybe the roads will allow you to have a maximum 20-25 millimeters of sag. So imagine here you've got a road, yeah, and here you've got a retention system, and this is going to be your cut void. Maybe you have a lower level here, another road or a river, whatever you have got here. So sometimes they will say, we don't mind if this is going to sway by 20 millimeters over 20-25 years, because maybe the soil will creep or whatever going to happen to it. So it's going to add more load. So they don't mind. So that will help the engineer to make smaller sections. But in other habitable areas, maybe they want to limit that to 15 millimeters. So that means it's going to impact your design as well. So that's what we're talking about, what you really want to use it for, because structures may lean. Sometimes it doesn't matter. Let it move 20 millimeters. It's acceptable. It won't really bother. It's just a highway, but we don't want it to fall down. So that's all agreed about. Right. So these are just the main factors you always need to think about when you go through such projects. In terms of cost, yes, it just changes depending on the construction process, site conditions, and the size of the site. Obviously, if you're digging for one level basement, it's definitely different than 2 levels. Not only that, sometimes you want a shopping center with 4 meters level or 5 meters level. but for a car park, it can be as small as 2.7. Talking about the head heights. So this is again the ground. If you excavate for car park, this can be as small as 2.7 meters deep, just one level. But if they want to build a shopping retailer, they may need this to be 4 meters. So again, that's cost, because you're going to need more propping, more, even, you know, more soil. You know, that soil you excavate, you have to think about transporting that soil you're excavating to the correct places. Depend on the council where they want you to place it. All right, so that these were just factors you need to know about as we go through the assessments and also through the lecture notes. Now, what we're going to be covering in this week or these 2 weeks, we're going to be talking about 3 types of piles. They have different terminologies, and the slides will tell you what's the difference between each. Now, just to let you know, today or this week, we will talk about the type of piles, the components. During the workshop, I will start showing you the engineering drawings and the project I want you to learn from, so you can answer again your questions. Next week, we will talk about the construction methods. Like, we're going to talk about equipment used and construction methods used to build such piles and systems. All right, so today we're just going to talk about the components and more specifically those 3 types of retention systems. All right, and that will be enough for you to maybe study over the week. Next week, we're going to talk about equipments and how they are used, what the challenges and the construction techniques. So the main form of retention systems, number 1, they call it soldier pile wall systems. Second one, contiguous pile wall systems, which I will tell you what's the difference. I know you're just now reading names, but I will tell you what do they mean, what each one means. Secant pile systems. Now, the main difference between each is how the piles are spaced, or how far the piles are placed between each other. If we look at the plan, we have many pictures that will show you. So quickly, these are the piles I was talking about, which I will talk to you about how they excavated and the steps, etc., etc. Between the piles, don't think they're going to keep the soil like this. They're going to pour we call it a shotcrete wall between. They're going to pour a concrete, and there's a process to do that, which we're going to learn as well. So I have maybe a picture. Here we go. That's the process. This is how the wall is. So this is again the pile, which we built at the very start. There is also a pile cap on top, which we will talk about. And there is the shotcrete wall. Now, those 3 forms I was talking to you, number 1, pile soldier systems, contiguous, and the last one, secant. It really depends on how far these are from each other. So that's basically the difference. This one is a soldier pile system because the spacing between the piles are decent spacing. It can be between 1.5 and more, even it's more than half a meter. So once the piles goes more than half a meter spacing, we call it the soldier pile system. They consider this is the soldier. This is soldier element, which really remember this pile is dug. Just a rule of thumb: if the basement here, the pile will get into the ground. Will get into the ground 2 times the basement of the height. So if this basement height was 3 meters. Right, say this is 3 meters. How many meters is going to get into the ground? Can someone answer? How many meters the pile going to get into the ground? Assume this is the natural ground level.
6 meters, sir.
Correct, 6. So overall, it is 9. Okay, so this is just a rule of thumb, but the engineers will tell you that there are other considerations which we can do to reduce that 6 meters embedment. We call embedment. So the student Ivan, who just mentioned to me 6 meters into the ground, they can be reduced to 1 meter if we are able to put an anchor here, which I will talk to you about. There's ways where we can put an anchor, like a nail into the ground, if it's possible. We will talk about these kind of features and details and challenges later on. For now, what I want you to understand the three forms. Number one, soldier pile system. Number two, constituous pile system. Number three, secant pile system. The difference basically is distinguished by the spacing between the piles. When they are about 100 to 200 millimeter away from each other, they are called contiguous. Okay, right? And when they are connected to each other, locked to each other, they are called secant. Right? We're gonna see those. We're gonna see those examples, and each type will be discussed over the lectures. Okay, so these are the three forms. You should know about them. In terms of how each is built, almost same. They are all built in the same manner. They are almost except the one which is integrated with each other. Right? So we'll have a look to each type. Now, what I'm showing you here is the equipment used, but we will again not talk about the construction method and the process. That's what we're going to cover next week. Today, I'm just showing you kind of what's called the auger. The auger is this part here. This part, it is the drilling end, the end which will drill into the ground. We call this an auger. All right. Now, this will sometimes, if the soil allows you to do this, you can start straight away with an auger, especially if you got clay level here. If it's a clay, kind of sticky, kind of cohesive, we can start with an auger and straight away go and dig for your pile, whether it's 600 diameter, 450 or 900. Now, on this side, this picture here shows you a drilling bucket. We use it if we got a sandy area. If we got a spot that's really sandy, we can't start because usually you may have 1 meter. As I said to you in other topics, sometimes we have fill. Fill is just a very loose material, which it's very difficult to work with. Whenever you excavate that meter or 1 or 2 meters or 1.5, it's going to collapse again and again and again, and you can't really progress. So what we do in such condition, and remember, you're going to be having a decent soil report. That was done 1 year, like many months ago, and you will know the topography and what layers you have. So if you have a sand layer, you will start using a bucket, which will, as you excavate, you can prop around it. We will see this next week, so don't worry about the construction methods and ideas. I just want you now to know about the terminologies and components and names. All right, so auger is part of the excavator, and it will simply just dig into the ground. If you have a clay, if you got kind of a bit of rock, you will be able to use it straight away. But if you have a sand layer, you kind of need a bigger hole. It's about 1 meter diameter, and then not only that, don't expect that you're going to excavate and then pull it out, because the soil will collapse again. We're going to put some shielding around it to retain the soil temporarily. And then when you reach that stable soil, the clay or whatever material, which is cohesive, you start using something like this and dig below that 1 meter or 1.5 or 2. Right. Now, as I said, retention system, the first form we're talking about is the solder pile walls. As I said to you, that is the plan view. That's looking from the sky. It's a plan view. During the workshop, I will start sharing with you a project which shows you how such things are documented in a real environment, and sort of details you need to know about, and again, what we're going to be asking you to answer. Right, this is just kind of a simplified presentation. These guys are the piles. These are piles, and you can see they are spaced with a decent distance. As it says here, can be the spacing of the piles can be up to 5 to 8 times the pile diameter. That's what I was talking about, right? Now there is usually those soldier pile walls, they are cast in situ concrete board piers. They're not precast, right? So, and that's what we're going to be teaching you, how it's built. We will take you through that, whether today or during the workshop, how these are built in terms of their construction techniques. All right. So one thing, the first thing you need to know, they are not board piles. They are not kind of precast and hammered into the ground. We will talk about this in, I think, next week as well. The process of hammering the piles in the ground. That's if you have to use it. Sometimes you can't really get all those concrete supplies on site, and in this case, we use the precast piles. We'll talk about this next week as well. So soldier piles, first thing you need to know about them, they are cast in situ. Board piles or piers. You know, piles, they are with reinforcement. Piers, sometimes they are without concrete. In small residential projects, we don't need to put steel. Because they are just taking compression in case required. Piling ring. Yes, this is there is a piling ring. As I said, we use a drill pocket or continuous flight auger. This is just an equipment, special equipment. We will talk about this next week. So this one, we use this process in case we have really stable soil where we need to dig for the pile. Again, let me show you a sketch here. This is the ground. We're going to dig for that 9-meter deep pile. In case you have a soil which can really be stable, it won't, like it was super clay and with rock, and it won't collapse. Yes, you are able to excavate the hole, right? And then put your steel cage. The steel cage, you put the reinforcement, then you pour the concrete. If we can do such excavation and the soil was okay, the surrounding soil was okay, then we can use the drilling pocket or any piling ring. Now the continuous fly auger, CFA, we will talk about carefully next week. It is which is widely used, mostly used. The soil conditions are not stable and things will keep collapsing. So what we do in this case, we, especially, when we go beyond 3 meters deep piles, like you can see many residential applications, they use this one here. They use this process, just the piling ring or the drilling bucket, because if you're excavating just the 3.5 deep piles, but once you go to 9 meters deep, definitely things will collapse. So in this case, we use continuous fly auger. What does it mean? You will excavate, and there is a pump that will take the waste out. And before you start lifting up your auger, the excavator end, which is this one, before you start lifting this out from the ground, you will start pouring concrete. So this acts, we're going to see it next week, this acts as an excavator and a pump together. So it's actually going to excavate. Once it reaches the bottom of the pile location, as per the design, then it will start pouring the concrete. So it excavates and pours the concrete. So that's really the CFA process, which we will talk to you about next week and show you some videos and some examples about it. All right. So as we talked about this point here, it's spaced with such distance. So if the pile diameter is about 900, then 5 to 8 times that diameter will be the spacing between them. All right, so typically used when sides of the holes are self-supporting solid ground. But why? Because remember, who's gonna really guide you to know which one to use? It will be documented on the engineering drawings, but before that, the soil engineer, the geotechnical engineer, the soil engineer will give you a report telling you this is what you can do. the way it works is this soil, the brown color soil here, if the soil engineer found it's got mechanism to bridge over, because remember, this is built at later stage. This day one, we build these ones, right? Day one, we're going to build the piles. Then we're going to build a pile cap on top. Then later on, we're going to build the thin shotcrete walls. Now, the thing is, from the time we build those up to the time, maybe it will take 2 weeks or so to build that. Is the soil able to bridge over itself from one pile to another? That's the question which will be answered by the soil engineer. They will give an advice in terms of how far they need to be separated from each other. Right. So, and based on that, the structural engineers will be designing such walls, and that's what you're going to be building. Sometimes, as construction goes, they will find a whole side of a basement is actually more stable than expected. That's where the construction engineers can come back to them, other engineers, and tell them, we're simply just finding rock, like what you see in this picture. You see, this is very clear, it's very stable. It's kind of floating rocks, you can see here. So if you found such thing going all the way down, you just can't go without worrying. Maybe the engineer can tell you, or like the soil report can say, no, you can go even far away. You don't need to go every 1.5 meters. You can go maybe every 2.4 meters, right? That's where you can make more and more money and save more and more time. So you don't need to put in this side 25 piles. You may end up putting only 18 piles. That's cost, that's time, etc., etc. So yes, the soil report may tell you, may advise us in day one, you put the piles no more than 1.5 spacing. That's what the structural engineer gonna design, and that's what you're gonna aim for. But as you excavate, you will find things is actually, sometimes builders will just go and do excavation, more checks on site just to make sure they actually need to do it. Okay, so that's really how the decision is made. And as we said, if we start getting the spacing between the piles to be up to 5 times the diameter, then it is called a solder pile wall system. All piles are reinforced. Yeah, definitely. If it's a retention system, it has to be reinforced. I said to you, some of them are not, in case they are just taking compression, like they just piers, they just vertically supporting a house or a small. So, but if you have something which needs to retain, this is definitely going to be under what type of action? Under flexure. Because when this is gone, you excavate here, this pile gonna tend to flex this way. So it's under bending. So we need to put reinforcement inside it, right? Now, when they build, sometimes we got a fill and we have to build a house on top of that fill. We use board piers where we don't need to reinforce it because we just want it to take compression load. We don't want it to take flexion. That's a different. We're not studying this week or in this subject. We're studying the members which are under. Wow, very nice question I'm having. We definitely gonna see, I'll show you videos. Adil, with the C, I've got question online. How we put the reinforcement? How we put the reinforcement? I will answer you now. I will answer you now because we're gonna see videos showing you what they do. When you, let me draw that again. Let me draw it. This is your ground. This is your pile. Yeah, as I said to you, now as we excavate with the auger, they will lift the auger up and they're gonna pump, right? And then all this is gonna be filled with the gray concrete. Let me find the blue color here. This will be filled with concrete. Imagine this is only concrete, and your question here is how you are gonna put the steel. Simply, they're gonna get a crane carrying the cage and submerge it and keep pushing it down. And I will show you a video how the contractors are having fun with that. They will just keep pushing it down because remember the concrete is wet, so they have to do it straight away after. All right, we'll show you videos about this next week, and you can actually find them. You get the answer? So they just submerge it. Okay, now coming back to our, so this is very clear, yeah. It is maybe in a final exam, I will give you a picture like this and tell you, please tell me all the details we are seeing here. So I will take you through the details this week and next week and over the workshop, so make sure you know what we're talking about. Now, definitely at this stage, I can see the piles already built. This is what we say the pile cap. So in day one, what we do, we excavate for the holes, whether it's going to be by drilling only, whether it's by the CFA. This is up to the condition. If it's very strong soil, which was agreed by the soil report, we just excavate. But I can tell you, as a 98% of the project, which goes like a large projects like this one, where you have 2 floors of basements, you're definitely going to go with CFA. You can't risk it and get collapsed, right? So you use CFA, you can excavate the hole, fill it with concrete, put the cage. Then when they put the cage, I will tell you something critical. You have to leave the steel bars sticking up, because after we have the steel bars sticking up, we have to pour what we call it the pile cap. This is called a pile cap. We have to put it because it's going to tie everything together, the pile cap. Then we start, remember, we pour the pile cap and we still did not excavate this side. So there is a pictures that will come to you. Before we actually excavate here, we're going to be pouring the piles and we're going to be pouring the pile cap, right? Then we will start excavating here. There is a picture which would show you. Let me have a look. So see, have a look here. Exactly, this is a case study. Yeah, we're going to go through this slowly. So this is in day one. Day one, this is the ground. I would say maybe the basement's going to be here. See this side? This is where the basement going to be, because I can see they started excavating here. And see how they do? They batter the ground, they slope it, they can't cut it in a vertical. Sometimes the builder just want to start speeding up, so they start cleaning from the middle of the basement. But the retention system is just this line. You see it? This line. So day one, you locate them as per the engineering drawings. Then you start excavating the holes, filling concrete, putting the cage, then excavate for a trench. Hopefully it's next page. Yeah, here we go. They're excavating. Yeah, they're ready. This is the UGO. Yeah, they got a pump, will be connected to it to put concrete. And that's there. These guys are sitting on the side. Oops. And the first thing they put is the piles. We have to get some bars sticking out because we need to connect those guys with the level above and the pile cap. Then they're going to pour. Don't get confused. This is not a pile cap. This is just preparing the ground. Still the pile cap going to come and sit on top, right? I will take you through all that again. Here they're putting the reinforcement for the pile cap. And they're going to put, that's until now we did not excavate for the basement. We did not do that, right? As soon as we finish pouring the pile cap, we can start excavating for the basement, and you will start seeing. So this is, again, we just put the pile cap, and I'll talk to you about this. Here we still did not excavate. The basement going to be here. We did not do it yet. Maybe they're digging in the middle of the slab. Yeah, but here we did not excavate yet. Let's move on. See, they started now excavating. They started excavating. And okay, now how deep we go? We go only, this is again up to the soil engineer and instructions. Typically we go 1.5 meters deep only. We go 1.5. Let me jump back to the first picture because we're going to come to this project later. So what I was trying to show you here, in day one, we drill holes, excavate, place concrete, place the steel cage, then build our pile cap, Yeah, this is a pile cap. Maybe that was a different project, but see here, the pile cap, even they don't pour the pile cap to the very top. Why? Because later they want to engage the concrete floor on top of the pile cap. They left some of the, maybe 20% of the pile cap still exposed because they want to engage it with the ground floor slab when it's going to be poured above. All right. Now someone going to tell me why here we got bigger, like because that's where a band beam going to be sitting, a concrete band beam going to be sitting here. Okay. So I know there's a lot of information coming to you, but that's where you have to carefully go through the activities and assignments. You can see here we got band beam, slab, and you will see these things. We're going to see these things in the example I'm going to share with you during the workshop. All right. At this stage, what I want you to know is to know in day one, we don't excavate the basement. We just excavate the holes. We build the concrete, whether by using the CFA method or another method. But if we use the CFA method, we will excavate, pour the grade concrete, submerge the reinforcement. Then the reinforcement needs to be lapping with the pile cap. Then we're going to build the pile cap. Then when we get, and the concrete sets, when the concrete get hard for the pile cap, we start excavating here. Now we don't excavate the full basement 3 meters, it's still risky. We have to go typically halfway. So there is, again, it's written in the structural drawings. They will tell you 1.5 meters down only. Then after we excavate 1.5 meters, we do this. What we do, we start, that's what, I think, yeah, that's what's happening here. Remember, this one is different, something different. What we did here, we put the anchors. So as I said, we use the anchors in case we can't go too deep. Sometimes, you know, when I told you the embedment will be 2 times the basement level, yeah, when you've answered 6 meters, when the basement is 3 meters, embedment is 6 meters, if the basement is 6 meters, right? Now, sometimes you find very rock ground under the basement. You can't excavate, it's too expensive. If you have decent raw rock bed below the basement level or like within that depth, then we have to think about alternative options. What we do here, we just embed the bottom of the pile by 1 meters below the basement level, and we use anchors at its top, close to the top. So that's a different consideration and different technique if required. And again, if the situation allows, because sometimes this anchor usually will go probably 10 meters into the soil. The question here is, are we allowed to do this? Most likely, yes, even if it's not your property, because the council will accept that. Usually we are allowed, but you have to make sure don't damage the neighbor's system. Okay. So we'll talk about these things. That's because I've seen it here. I just wanted to talk to you about it. Maybe in that project, they needed to use anchors. So where I was at is, what do we do after we excavate halfway? We have to prepare for the shotcrete wall. What we do, we put this little thing here. We call it a drain sheet. Okay, a drain sheet. What does it do? It will take the hydrostatic pressure. If there is a water table rising up behind the basement, structural engineers they typically don't allow for the water to be behind because it's going to be even more expensive to concrete and design. So what we do, we put this drain strip, and it's typically going to be between each 2 piles. Yeah, going to be between each 2 piles. And if there was a water level rising behind that wall, it will be all collected by this drain strip and then connected to the stormwater system, right? So we put this first, we put the reinforcement, the mesh for the shotcrete wall. Then what we have to do as well, we have to drill some bars. These bars are drilled with epoxy, so that we drill, we put epoxy, then we put the bar. Number 1, we drill on the side. All those details, I will let you read them over first engineering drawings, so you know what really it means on the drawings, and you will see them as well physically here. So we have to do kind of three things when we're ready to pour the wall. So let me say it from the very start. Day one, we're gonna excavate for the holes. So no cut, no basement. We're gonna excavate for the holes. We're gonna pour the concrete. We're gonna put the cage, right? If it was a CFA method, then we start excavating. Sorry, before that, we have to put the bars for the pile cap. We have to pour the pile cap. When it gets hard and sets, we will then start excavating. It's up to the engineer. We can't go and excavate for 3 meters in one go. If it was okay, but usually it is one like halfway. Now in this project, it seems that their piles will not go 9 meters if it was one basement. It did not go for a decent double basement height embedment because probably there was a lot of rock. So what they did, they only went 1 meter deep below the basement level to just anchor the bottom, and then they used a nail. They used a nail which gonna go, which will support the pile at this level. So that's another process we do before thinking about placing the shotcrete wall. Then after this, we're gonna think about building this wall. To build this wall, we have 3 main steps to do. First, you put those, we call them starter bars to the side. Starter bars, you're gonna see them on the engineering drawings. How they place them, they drill, they just drill maybe 250 or 300 into the pile. They're gonna put epoxy. Yeah, there are like 2 main brand names available in the market. They're gonna put epoxy, then they're gonna push the bar inside for those 300 to 50 millimeters. Then they just need to wait for several hours and they're ready. They do this every, say, 300 up to the engineer. And then they're gonna place the mesh, right? Sorry, before the mesh, they're gonna put what? The strip drain to collect all the hydrostatic pressure and water behind. Place the mesh, then they're just gonna spray the concrete. That's it. So this is how it looks now. This is maybe not the end basement level. There is more excavation to come, which you're gonna see clearly here. So see what happened here? They poured the concrete, the shotcrete wall. They poured it, and then once it's set and ready and strong, they will then this, you know, they do this because they want to make sure they're going to stabilize the soil behind. They can't go all the way those 4 meters, whatever it was deep, because it may be unstable. All right, so now they're going to excavate for the other 1.5 meters or whatever it was possible. And if yes, they're going to connect more. There is a kind of splice connection. You're going to connect this, an extension to the strip drain and take it all the way down below the basement level to connect with the stormwater system. Right? So where we are at, yeah, that's it now. Once we do same thing, we're going to put the bars, put a mesh, and connect some bars to the top side as well here to make sure this all going to act as one piece of wall. And that's it. We get now to the basement and start thinking about building the basement. Are there any questions from those pictures we've seen? Are there any pictures? Sorry, are there any questions related to the pictures? Something not making sense? So that's all was about the first type. We called it solder pile wall system. Right? All right. This is just a structural engineering plan view for, I would say, that development you've seen. You can see here these lines, and these are the piles, right? They're quite spaced very close, but maybe the scale here is too large. So these are the piles, and you can see these lines behind. They represent the nails. They're anchored. They are anchored. These are the anchors. These guys here. Now, I will talk to you next week about what's going to happen with those. So they don't stay like this part going to go away. Usually this is just temporary because this is kind of pre-tensioning as well. So there is a process which I will show you with videos and explain to you. They're going to be using special equipment that will create a hole through the pile and all the way 6 meters or more, whatever the engineer wants, into the soil behind. So they're going to make that, say, 100-meter diameter hole into the pile and into the soil. Then after that, they're going to inject some concrete, right? And also before that, actually, they're going to inject cables that they're going to be tensioning at some stage, which I will take you through that process next week. We'll show you some pictures and talk to you about the process in doing that. So first of all, they're going to have, say, 100 diameter holes with special equipments. They're going to drill through the pile and drill 6 meters to the back in the soil. They're going to inject cables with an onion, like a special dead end, to get anchored at the far end. Talking about this end here, this end. Yeah, you're going to inject it all the way there, and then they're going to pour concrete because it will help to bond the cable with the soil. Then they're going to tension the cables to make sure it's very, it's stuck. And that's what they do for those anchors. But one thing I want to tell you, in some projects you don't need to do that, in others you do need, depends on what's really in the ground below the basement. Do you have a lot of rock that you can't excavate through? Then we're just going to go 1 meter and stop it there and use anchors. If you have a softer kind of soil, you can go easily 9 meters into it. So that's fine. Go in. You don't need to put anchors. And we will show you both examples. All right. So that was just the plan view from the structural engineers, just showing you the placement of the piles. Those little circles, they are a pile. Between them, they're going to be shotcrete wall. They will give much bigger scale details to show you what's happening here, and that's what I'm going to show you on the example, the school example we'll talk about Wednesday. And this is just showing you the nail they put behind. And definitely they're going to have a section here, which will show you how it's all working and all the dimensions, specifications, etc., etc. All right, we're still talking about the soldier pile system. This is again a section, but it's simplified. This is not an engineering drawing. They're just simplifying things for you. Just telling you up to where the piles will go. So usually what we're talking about, the problems with the solder pile walls, not suitable where high water pressures or flows exist in the soil. Yes, definitely, because here we've got a big spacing. Yeah, you've got large spacing. And if you're excavating before you have these walls, it will, the water will just throw the sand material back to you. So it's really not helpful to have such big spacing if you've got a water table issues. By the way, this is just, it's also called soldier pile wall system, but we use steel in this case. We are able to do that if you don't want really to use concrete piles. It's just another option, but just same system. And as we noted here, it's an old system that's used. We need to know about the old systems because usually you can also be involved in existing projects to modify or remove. So you need to know how things are working. So that soldier pile system usually is the simplest, fastest, and cheapest because you don't need to put the piles at very close spacing. You can put them away from each other. And yeah, the industry knows it very well. They know how to do it. They know how to do it very well. And most of the basements are done based on using this type of retention systems. And as we said, use with ground anchors for deep excavations. And also when we have that rock issues and we are limited with the excavations, as discussed. Now, contiguous pile system. It is just same thing. You got pile and you got a little bit of concrete between. But the only main difference between this one and the soldier pile system is the spacing between the piles. The nominal gap is 100 to 50 or 50 to 100. All right, 100 to 50 millimeters. And definitely you would think about using this if you will definitely need to use this if the soil is very loose and the soil engineer said you can't have such spacing. It will not work. Definitely things will collapse on you. And that's usually happening in like the southeastern suburbs. Usually you got a lot of sand there, and definitely a system like this cannot work. You will keep excavating forever and you can't really handle it because it's very close to the coastline, the beach, and it just the sand still collapsing. So in such sites, you would think about using secant, where the soil will be blocked within those 100 to 50 mil gap. All right. Yes, so the soil is will be this small gap will be exposed during excavation, but self-supported due to arching effects. The arching effects is basically what I was talking about here. Arching effects, you know, when I was telling you, it depends on the soil engineer to determine is the soil able to arch and bridge over the spacing. Same thing here. The soil engineer would determine the 100 or between 100 to 50 mil gap, the soil is able to arch through this little gap. So same kind of concept. Okay. Used, as I just said to you, used in sandy soil conditions. Sandy soil, definitely you can't go with the salt gel pile system because it is very large spacing. All piles are reinforced. Same point we had for the salt gel pile system. We need, because they're going to be eventually under flexure. So we need to have the concrete reinforced with steel. Infills, like then usually what they do, sometimes they even don't need to have that bumpy look. They may actually pour the concrete. They may just leave 50 mil gap here and pour a straight line concrete to have a nice wall finish, right? To have a nice wall finish, and they can fill the gap as well. Still, this system will not be handy and helpful if you got water table issues. So that's what we're saying with the last point here. Suitable when groundwater is below the maximum excavation. And in case if there's water table, definitely the water will, if you do the excavation maybe after a break or after a weekend, and if it was rainy, you will again find the soil, the basement full with the water or full with saturated sand, etc. So that's again a cost and a problem, and it will destabilize the system. In that case, definitely we're going to go with the third type, which is the secant pile method, which I will show you as the last type. Some pictures showing you those contiguous piling system. They are very closely spaced, and it seems that the soil here is a sand material which cannot withstand more than about 100 millimeter gap, which is specified by the soil report or the geotechnical engineers. All right, same concept, nothing new. You still have a gap. Day one, you're going to do the excavation. The only thing I would mention to you, we use something we call it hit and miss. What does that mean? Hit and miss means it's difficult for the builder to excavate this, then that, then this, because the holes are very close to each other, right? So what they do, because they can't do this maybe in the same day. So what they do here, they're gonna do the blue ones. They're gonna hit one and miss two, and hit this and hit that. No, they're gonna use hit and miss method. So day one, they're gonna do every third pile. They start with this, then or every fourth pile. It's really, again, they're gonna be a meeting between the construction engineer, the soil engineer, and the structural engineer. And they're gonna discuss this. They're gonna tell him you have to do every third pile or fourth pile or second pile. definitely the builder want to do them closely spaced because he just want to smash it and finish this job and you know, get paid for this part of the construction. But again, depends on the soil condition. I would say every fourth pile, like every blue one here, then in the second day, not second day, after the blue ones are set and hard and they reach the acceptable strength, then they're gonna do the yellow piles, the one I'm just going over. Hopefully you can see them. Yeah, then that's in maybe after 3 or 4 days, they're gonna come and do the yellow ones. And same thing, they're gonna use maybe the CFA method. They're gonna pour the concrete, place the bars, and then on a third day, on a next week, after a week, they're gonna do the green ones. They're gonna do this one and this one and this one. We call this hit and miss. Okay, so we do them at different stages. Now I have a question for you. Why we have those bars lying above the basement?
These are basically for the top, what you call it, the
That's
pile
right.
cap.
I know that you know the answer, but yes, someone said connection and you know what I talked about, but you still don't know the terminology. That's fine. The pile cap. There is a pile cap that will be placed here. There is a pile cap that will be placed here, and all gonna be connected together. Okay, so yeah, this is the, you see, yeah, that's what's happening here, and this is the reinforcement. Yeah, see, I was telling you the pile cap, which have to be placed before excavating. So the basement is somewhere here. That's what we're gonna excavate, right? Before you excavate, you have to place the pile cap. You know, the questions that we will ask you, it's about the steps, the process, what's this, what's that, why we're putting it. So make sure you understand all those details and terminologies, and that's all really what we're trying to teach you in this subject and understand. Okay, what else I would tell you from here? Yeah, one of the, in the past, which I was aware about, there was a killing mistake that happened in a site, is they actually poured the piles up to this level. Yeah, there was a very young superintendent. Superintendent was the engineer who looks after the process of building a retention system. What happened is when they poured the piles, right, they didn't, so if you see it from the top, is there a better picture to explain this? Ah, here we go. This is it here. So instead of stopping here, the pour, they stopped here flush. And you know, they're going to excavate later on for the trenches, and that was a killing mistake. They need to jackhammer each pile. And jackhammer was a problem because you don't need to jackhammer the top and then you may crack all the pile. The engineer advice there was you have to carefully saw cut them piece by piece. You have to saw cut, you have to remove that gray concrete slowly and expose the steel. Nobody knows what they actually did. They maybe got a jackhammer, but that's again, so it was a big delay in the project and a lot of additional costs. So allowing for this, it's really critical, because that's where you're going to have your pile cap. See, it looks something very simple and basic, but if it was missed in a project, yeah, you kind of costed the project a lot of monies. Okay, any questions? This was just pictures for the second type. This is another picture, shows you when we, you see, we can even achieve higher depths here. That's very, it looks to me clear, 3+ meters deep, right? Because yeah, the piles are doing the job here, the contagious piles. Yeah, it's almost now, maybe that's the finish level for the basement, and then they're gonna pour a very nice wall that will cover all that look, and it will fill all those little 100mm gaps. Looks very clean and very nice excavation here. Now, usually, as I said, you will see this if you go like in the CBD or in any shopping center with a decent basement. What is that place? Yeah, there are many shopping centers and there's a basements. You're gonna see there are piles below there. They don't mind to see that look there, but if it was a habitable area, the architect will specify to pour concrete to make it a nice wall, flat wall. Okay, that's the last one. The last secant pile walls. Secant pile walls. Yeah, the third type I'm introducing to you, it is this one here. You can see they are definitely the use of this when you are working with silty, sandy soils likely to collapse and fall in. Who will tell us this is the soil report, and the engineer will adopt it accordingly. If you got water table issues, so as it's specified here, it provides some degree of water retention, but it's not watertight. So what does that mean? If you really want to water, like if you go to any basements I was talking to you about, you're always going to see water leak from here and there, which is fine. It's not the end of the day. If you want watertight, you have to actually put special waterproofing material, which can be looked after by the architect to specify. All right. So all those three systems, they cannot guarantee like there won't be moisture coming from the walls. There always things gonna happen. But if you really want a watertight finish, then there are special membrane materials that can be used whether behind the wall. So that's again different packages and different techniques. You can either spray it or you can just place it behind. So especially for corner stages, it's difficult to do, but this one here, talking about this type, you may be able to put special membrane behind all those if you really want to have a better, or you put it from the inside, right? This is again what like some other, I will show you in that example. Wednesday when we look at it, there are sometimes they leave a gap. That in that project I'm going to show you, there was a gap between the retention system. So if this was your retention system, let's say this was the piling, the shotcrete wall is in the middle here. What they do, they leave a gap here, say 100 mil, and they're going to be a stud timber wall. That was because here we had classrooms, right? And what they do, in case there was a concrete, the basement level here, and the piles goes into the ground, what they put here, a spoony drain. A spoony drain. That's just in case there is some water leak or moisture, it will be collected by the spoony drain, and then this should go and take it to whatever hydraulic system you have in the project. Okay, that's just another way of reducing moisture into, but this is purely architectural detail. If it's written there by the architect, you follow it. If it's not you just don't do it. But just for your understanding, there are different processes to stop that leak. All right, so we were at this third type. And so what's happening here? We've got the main piles, right? We got, we'll maybe show you a video about the construction process for this next week. It's a little bit different than what we showed you. For building this part, it can be same as the CFA method I mentioned to you already. But for building those ones, like one of the methods, they build the unreinforced sections, the ones in between first. So they build these ones first, right? And before they actually get hard, they got to the, like while it's still kind of excavatable. So what they do, they build this one first and this one first, and they just pour mass concrete. Then before it's get hard, so you need to be careful with the timing of excavation. They're gonna come and excavate for this, all right? So there is a process. There are different ways, but one of the methods is you're gonna be building the non-reinforced section first, right? But you're gonna do them at stages. You don't do them all in one go, because obviously if you're gonna do the whole line, they're gonna get hard maybe next day. Like in the same day, you have to plan for pouring maybe 3, right? And in the same day, while it's kind of still excavatable, you're gonna come and excavate these 2, the reinforced ones, because you're gonna go through the concrete you just placed, and you will place the required reinforcement, and then all that section will be done. Right, so talking about constructing this section, you're gonna be excavating for the non-reinforced section first, pour the non-reinforced as they are, like a full circle, and without reinforcement. Then after they 30% hard, they still excavatable. You're going to excavate for the reinforced piles in between, as shown. And you place the reinforcement as discussed, and that's it. So this section is done. Okay, so obviously with these ones, they will definitely stop here, and they will make such arrangements just to allow things to happen. And then they can start the next stage, whether same day or next day, up to the timing and how things work. So yeah, it is slower. It's got kind of some waste there, because you're placing concrete, then you're excavating it again. But sometimes you just need to have this process. The secant piles, you just need to have this, the piles sticking to each other, right? So you can see this concrete here, which I was talking about wasting. It's very, very cheap concrete. It's only 5 MPa, because you're just using it as a gap filler. That's all. It's a gap filler. So they don't need to be expensive. Like the primary piles, they can be 25 to 32 MPa with reinforcement. This type, as we discussed, gonna give you some much better water retention. If you got a water table, if this is a project that must be built within the wet season, when you've got water levels up, that's it. You just use this, and yeah, they use these areas, maybe these methods in the wet areas as well. All right, so the overlap and the overcut is about 75 mil. We're talking about this overlap. It is about 75 mil to make sure things are engaged together, and the whole system will form a continuous wall system. All right, now let me ask you, this is just an example for such piling system. Yeah, you can't see because still the soil behind. They may spray with high pressure and then clean it up. My question, someone may come now and ask me, why are we bothered to not really build it as a wall? And someone tell me why. Someone will say, why are we going through all that headache? Putting pile and secant and one that cutting it in. Why we just don't build a wall like this, a 200 or 250 thick wall, and happy days? Can someone answer me why?
Costly?
No. What costly? You're spending almost the same quantity of concrete here, isn't it? Costly in terms of what? But why? Why it's costly? Maybe it's to do with cost, yeah, but why? What's the reason?
I'll try. Because of the silty and sandy soil, excavating a wall will somehow make the soil collapse.
Okay, yeah, we're getting there. Yes, yeah, it's all about why we're studying this topic. That's right, because there is no physical way to build a wall. I'm just trying to open a new sheet and explain that to you. How can I open a new? They keep changing the way of doing things. I just want to come up with a sheet. Why they made it? Yeah, here we go. That's enough for me. So, right, let's go back to the reason why we're having. This is the ground floor. This is the dirt, the soil, right? Okay. And what I was telling you, why we can't build a retaining wall like this. A retaining wall, if you have built one or studied one before at university level, this is a retaining wall detail. You've got a leg, a footing here, yeah? And that's all what we know about retaining wall. That's what you study. So you build a retaining wall. This is the wall, the 200 thick wall, and there is a footing, like a foot. And then after you build a retaining wall, you can excavate and take away this soil here. You can take away the soil from your ground and you do your basement. So I was just asking you why we can't build this wall. It's just not possible. If you're gonna to build this wall, you have to cut the ground and at 90 degrees cut, and this is not possible. I can tell you this will be possible if you were able to slope, let me clean this. So day one, this is your ground. If you were able to actually, so in the future, we won't say to build a retaining wall here. If you were physically able to make a cut like this in your ground with acceptable angles like that, yeah, you're able to have here maybe 45 degrees and here 60 degrees, and then delete and excavate this part. So all this will be gone like that. Let me put a line here and a line here. So if you're able to have this now, yeah, you can actually come with this green color and build the footing and the wall and do this over 20 meters into the page like this. You keep going into the page like that. 3D. I'm trying to draw 3D here. But is this actually possible? Definitely no. Maybe, first of all, maybe here we got a boundary line. This red line, it is the boundary line. So this side is not your property. You can't actually slope them. You cannot do this, right? That's number one. Maybe you're gonna have already a building sitting here. Okay, so there are many, that's why we are studying the retention systems. So now why it's working with a retention or whichever type, secant or contagious or soldier piles, because the pile we're gonna take it all the way embedded into the ground. And as I said, if we're not using anchors, this will be 2 times X. X is the basement height if there are no anchors. And usually anchors will slow the project, will cost more. So yeah, it's better not to use them. However, if we have very deep excavations or like maybe 3 levels basement, or if we have large rocks where it will always prevent the piles to go through or very costly, then we can go with anchors. We have to anchor, and then we can have only 1 meter, not 2 times X, usually only 1 meter embedment. It's enough if you got anchors here, because like simply supported we can. So yeah, what I was asking you earlier is just while we talking, because when someone gonna look at this, they say we always putting the piles next to each other. Why we did not really just use a normal retaining wall we know about from undergraduate or we've seen it. The reason is this. The reason is we cannot batter, we call it battering the soil, sloping the soil. Physically, it's not possible. Like you do have sometimes builders coming to you and say, I want to put a precast panels. It's very easy because he's seen it somewhere. Precast panels like a wall, you just come and crane them, place them. We're going to study precast panels, by the way, in this course, because it's very fast, very, very quick to do. But physically, you can't. How are you going to excavate? How are you going to excavate you cannot just cut the ground at 90 degrees and expect it to stand like this and wait for your panels to come and sit. It's going to collapse, right? And also you're going to need some footing here. You have to think about it carefully, because here, if you've got a boundary line, the purple color here is a boundary line. Not allowed to touch the soil. Okay. And you have to keep it safe for the neighbors as well. So that's kind of the reason. The answer is because we need a retaining system, which was the case for the other types as well, whether contagious or solder piles. So this was a picture for a kind of secant pile system. I know it's a lot of soil, but you can see they are just integrated together. You will see these type projects only in a sandy area with high water tables. You won't see them much in many different projects. Yeah. Okay, so there is a table here just comparing between the three, which will be good for you to run through based on the slides I've discussed with you. If talking about the type of soil, contiguous, it is medium stiff soil. Secant, obviously soft soil or sandy soil. Soldier piles, they are widely spaced from each other. So definitely the soil must be self-supporting. Who really gonna determine this for you? It is the soil report, and that's what also will be advised by the engineer. So the engineer really gonna rely on the soil report, and you're just gonna be building what's specified. But as a builder, does not mean you have to blindly just go and hit and smash. You need to make sure the conditions assume role for construction engineer is they need to understand what the documents are saying. That's one. Number two, they need to make sure what's written on the documents is actually what's happening on site. Don't say, I've just assumed, like maybe the soil report, because they're always gonna put notes for you saying that's what we inspected. Remember, when the soil engineer is gonna go and inspect, they're gonna take maybe say 10 or 5 or samples from different spots in the lot, but there is always possibility where a corner in your site is different than the report. It's maybe just not the condition. So who gonna determine this is the builder, because they are on site and they know. So you just can't just follow the drawings and say that's what they said. Maybe sometimes you're gonna find a corner which is really sandy. Maybe you have a water table raised up, right? So maybe that corner need to be built as a secant pile wall system, and the other side can be. So you can mix actually between them in one side, depends on the situation you have there. Maybe, as I said, in the back you have an easement, which easement, as I said before, that's where the council placed the pipes below the ground and they filled on top of it. That fill material is very soft, it's not stable. So in that easement side, you may have secant pile wall system, and here and the rest will be just a soldier pile system. Yeah, so we're talking here, the groundwater should be below the maximum excavation depth for the contiguous pile wall. For the secant, it's possible to prevent water leak during construction or water going through. It won't give you 100% waterproof, but it will prevent the water seepage through between the walls. Not suitable for water tables. And if this one definitely, it's not a choice for you. So that was a simple comparison. Any questions so far? Do we have any generic question? We will have more during the workshop, maybe for 1 hour. I'm going to introduce you to a project which is it's going to help you to understand how these things are documented in a real construction exercise, which will help you also to answer your second assignment. And most of those pictures, I will visit them again once I start showing you the engineering drawings, the documents builders use to build them. I will come back to those pictures and show you what does that mean, what does this mean. All right, make sure you understand the process, the steps of what have been built. I know today we didn't talk about machines and equipments. This is what we're going to talk about next week. Next week, we'll talk about equipment. There are 2 types to talk about. One is the precast, and the other one is in situ. What we talked about, all the 3 types we talked about, they are in situ. They are built on site. Okay, piles can also be built in the factory and hammered on site. We will talk about that thing next week as well. Any question? Slides are not visible. What do you mean?
Oh, actually, that was earlier. I mean, now it was toward the end.
Now it's good. Maybe a glitch or something.
Yeah. So basically, there is this small question about the drilling bucket. So
yes,
when exactly do we use the drilling bucket? Because I'm a bit confused about that one.
No problem. So drilling bucket. So let's say you've got a site. This is your natural ground level. And let's say you've got 1 meter. Let me just make it with a purple color. 1 meter deep of fill. Very loose fill. You've got fill here. Now, ideally, the usual exercise is, let's say we need to use the SFA method, the continuous fly auger method, the one which is usually used, and then it's going to pour concrete. Now, if you have this site and you use the auger to excavate, this 1 meter or 1.5 meters or 1.8 will always collapse, right? And it won't help you to, because the auger is only about 300 or a bit less or a bit more diameter. And if you got a fill or a sandy soil, it will always collapse. So what we do, we try to use the drilling bucket, which is about 1 meter diameter. It will help us to, so if I clean this now, it will help you to go 1 meter decent excavation or even deeper. You can take it as much as you want to give you a large room. And then what we do, we're going to see that next week, we're going to put kind of a temporary propping sheet, like a cylinder. And those buckets can stay as well. So once you excavate, you can, your choice. Sometimes we keep them. So if we got those barrels, the ones that you're talking about here. Yeah, so we use these guys to actually go through that fill, sandy material, and then make a 1 meter diameter hole, right? And then we can prop it. We can prop that hole.
So basically the buckets, they go down and then we excavate at the top. Yeah.
No, the bucket gonna go down, excavate that one, like excavate the, so this, they act as an excavator. So they're gonna be excavated into the ground. and you're gonna pull out the soil. I think the next week's slides can help me here. Let me open this.
I don't
Because
know, but I can't actually see the screen of your laptop. I don't think so that it's visible right now. It's not to me actually.
other students, can you see my slides?
Yes, I can see the slides.
Yes. What about you, Adil, now? Is it better?
Just give me a second. I'll just reconnect maybe.
Yeah, so this is kind of what I was talking to the students.
Yes, now I can see the slides.
Yeah. Yeah, so all of you can see the slides, yeah?
Yes, and now it's visible.
Yeah. Right, so this is, you can see here the barrel, or that's where that's where we're talking about it's used. Right, so this bucket can be, say, up to 1 meter, 900 to 400, and it can be even more, right? You will definitely think about using it when you have more self-supporting slides, so things will not collapse. Okay, and sometimes we go with bigger diameter to stabilize. I do have another picture which will show you. Here we go. So sometimes we use, in order to place those, so why are we using those? Is we have very sandy, I was telling you, if you have a 1 meter fill, and let's say we need to stabilize it temporarily. So what we do, we use the drilling bucket to drill, say, 900 diameter through that 1 meter. And then while we take it away, while we put it up, the soil, we're going to place this because it's going to provide a temporary propping for us within that 1 meter. And then we can go back and use the CFA to go into the 9 meters. So that's if the soil we find it does not really withstand itself at the top. But if you are, usually we can go with those ones, the ones you're mentioning. If we have only 3 meters excavations and the soil is really stable, you still can use this all the way down to the bottom, but you have to make sure it is self-supporting side, which I said to you, we're talking about large construction sites, large developments, which we're trying to cover in this project, and the type of examples I'm showing you. You won't be using this. You will be using this only at the upper side of the soil, which is usually fill. It's usually not stable. Like the first meter, the first 1.5 meter, we will be using the buckets just to create a decent, stable soil and using those props. So we use these kind of barrels. So after we make, say, a 900 diameter opening in the ground by using the drilling buckets, then we're going to place this. Then that's it. We're going to use the augers. This is just the front part of the auger to go through it and start digging. We use this when we have very deep piles and the soil is not self-supporting, which is mostly what we're talking about in our examples. If you are in a soil, especially not within the CBD, like North Melbourne and all those areas, and the excavation is only, say, 3 up to 4 meters deep, then most likely you can use this bucket, the drilling bucket, all the way down. Right? You can use it all the way down if you want. All right. So this is the one I was talking about. Does that clarify?
Yes, sir, it's clear.
But one thing you need to remember, so if you're using that bucket and excavating for those 3-4 meters deep, it means that you are not using CFA. It means that we assume that the hole gonna be empty for 3-4 days. You need to make sure it's not rainy season, because we do have, you know, people go hire an excavator like this and get contractors to excavate maybe 20 holes. And next day when it's rainy, it's going to be filled back, even for residential. You're just going to need to redo. Okay, because you're going to disturb the whole ground. Usually you need to be careful with time. And what I'm trying to say, we assume that the hole's gonna be self-supporting for a few days until you're gonna place the steel if required and pour the concrete. You can use this bucket. But in the deep excavations we try to talk about in the subject, you won't be using this 9 meters down. You won't find the soil like this stable for 9 meters. So but we still use it only at the upper side of the soil or the ground, because usually the upper side, it's like what I was saying here, it's not stable. So we use the bucket to get a hole and put a temporary tube or barrel, the one I showed you, which I will talk about next week. And then we got the SFA to continue for 9 meters down into the ground. And that's it. And then you take it away when you get at the top, if required. Sometimes builders can clean the site already, and that 1 meter fill will go away anyway. So all good. All right, so we got about 10 minutes to go, and here I will just talk to you about a case study, which should reconfirm it's mostly we have pictures to look at. Those pictures, again, it will help you to understand the components, the terminologies, the process of building the retention system we talked about today. So it was a structure in Melbourne. The soil was moderate to extremely weathered siltstone and sandstone, so it's kind of in between, midway. I would say most likely they used, you can see here, it's kind of the spacing varies, so it's a soldier pile system, the first one we talked about. The piles were spaced. They got different type of diameters, depends on, again, on the height and the properties, the 6 factors we talked about at the start of the lecture. The size and the diameter of the piles, that soldier piles, depends on the factors we talked about. They vary between 450 diameter to 900 diameter and 40 MPa concrete. The shotcrete wall, the one we fill in between, was 150 thick. And the strength of that shotcrete was 32 MPa. The cover of the steel is this much, 30 millimeters. The cover, because that mesh I showed you placed cannot be stuck to the dirt, to the soil. Needs to have cover. Usually it's in the middle of that 150, if it was designed to be so. So let me ask you a practical question here. If looking from the plan, this is your pile. That was a pile. That was another pile. And here you've got a shotcrete wall, right? That's the plan view. And the red or the purple is your steel, the mesh. And I ask you now, where do you think the thick cover will be? Will it be on the soil side? So the soil side is here. This is the soil. Soil, right? And this is the basement. That's the basement, the hole, the excavation. My question, which side the 30 mil gonna be? Is it towards the soil side or the basement side?
Well, it says front, so it should be basement, I think.
Oh, that's given to you. Well done. You read the document very well. But let's say they didn't say that to you. Where are you going to put it? Correct. Basement
Towards
side.
the
Now,
both sides. It should be towards the both sides, like the clear cover, maybe. The concrete
no,
cover.
the front side is the front side. So the front face or side is this. Let me zoom in there. Let me make it looks more beautiful. So this is the cover, the yellow, this side. So it's correct. It is the front side. Why? I'm asking you guys, why? Why we have to keep 30 millimeters here? Remember, the thickness of the shotcrete wall was 150, right? So midway, if you set it in the middle, it's going to be 75. But usually it should be closer to the basement side, to the inside, not to the soil side. Why? Okay, think about the design concentration. When you have the soil behind, I will try to draw it with color, another color, let's say red. The soil will be pushing this way. Oh, sorry, that's black. The soil is pushing this way, yes? So the retention wall will be flexing this way. Which side going to be under tension? The basement side or the soil side? Which side going to be for the concrete? Which side going to be under tension? The basement side? Correct. This side of the will be under tension because we're flexing it. Remember portal frames. And this side, the soil side will be under compression. It's a flexure. So that's why we have to put the bars closer to the basement side. Okay. If this is what the engineer said on their drawings, that means that he intentionally wanted like this. You cannot put it in the middle. I know for simplicity, people are gonna just throw it in the middle. No, if it needs to be 150 thick and the cover is 30 to the front face, it should be built like this simply because of the design concentration. This element is under flexure. The soil is pushing it from behind. So let's have a look to this. Let's see when they built it, how it's looking like. Here we go. You see this shotcrete wall? Yeah, this one is actually under pressure, like the soil is pushing it towards us, towards outside. So it's going to be flexing like that. So this face is under tension. So we have to place the bars closer to this face. Okay. Now, I strongly suggest you to go over carefully these pictures or whatever pictures I share with you and understand all the details there because you can be asked to explain, annotate, and all these things. So this first image is showing you in day one before they actually didn't do anything about the past. They just kind of started taking some soil. Looks like it's a decent, maybe residential, and I'm not sure what, did they tell us what kind of facility is this? No, they did not. It's just a building in Melbourne with a basement. They wanted to take some material away because all these materials need to be transported to specific destinations. So depends on where the council wants to take it. So the builder wants to really get some material out. They want to start. But remember, they are still far away from the basement line. They cannot excavate with 90 degrees up to the retention system. It's going to collapse as we discussed. Now, first thing, they're going to specify where the hole's going to be up to the engineering documents. And this is the CFA construction method, which we will talk about next week. This guy is going to excavate, go 9 meters into the ground, whatever, and it will pour the concrete as it goes up. When it's going to go up, they're going to submerge the reinforcement inside it. Just a picture here showing you the holes correctly located and surveyed by you're going to have a surveyor coming. This is all done by a surveyor, licensed surveyor. You're going to ask him to come and position them in the right spots. So all going to look perfect. Then you bring your machine, another contractor. So you're just managing everything. You know what everything is called. You know what the process is. You're going to have, maybe you're going to be responsible of the excavation process only. Another one, you may be only responsible on the retention wall. maybe you're gonna supervising all of the, so nobody knows what type of role you're gonna be playing there. You'll have, these are the cages sitting around, ready to be submerged when the concrete is poured. Yeah, at this stage, this picture shows you after actually building and pouring. We're gonna see next week, we're gonna have sections talking about the construction process and the equipment used and all these kind of things. Just gonna be too long to give it to you in one day. But today, make sure you're understanding the process. What's built first, right? First, we dig the hole. Second, if we are using not the bucket drilling example, the bucket drilling example means you're digging a hole for 3-4 meters, putting the reinforcement, pouring the concrete, and all done. That's in a self-supported soil, and also when you have short piles, like within 5-4 meters, and if the soil is stable. If not, we use the CFA method, where we're going to dig the hole, use CFA method by which gonna, as it gets to the bottom of the pile, it will start pouring the concrete, and then you're gonna submerge the cage and make sure the cage or the steel is sticking out to get it connected with the pile cap. So make sure today you know the terminologies. Or this week, we're gonna talk more about, I'll show you this in the drawings to make sure you fully understand it. One of the jump here, they don't get confused. Clearly from the picture here, they did not build the pile cap yet. They did not build it yet. What they did here, they just stabilized the soil, right? Maybe here it was very disturbed soil, so they just prepared a strong base. So don't get confused. Some students think this was the pile cap. No, the pile cap should be coming over the piles and the steel of the pile cap. See, they're preparing all the shear ligatures, the bars. It's ready to be placed in position. See how they placed the, yeah, here they put all the cages and the bottom top reinforcement and ligatures for the pile cap. They are fully lapped with the, see, they're using as well the chairs that we talked about last week. And you're expert now in these things. So have a careful look through these pictures. If you have any questions, bring them to me, because I may ask you something about this. I will not ask you about what's this, okay? I will ask you about these things. Right? Then they have built, so this is interesting here, why they have a step here, because they just created a rebate for the slab to sit over. The slab, it will come and sit like this. This may have, I will show you this in the engineering drawings. So the concrete slab will go, so just to mechanically lock the slab with the pile cap, to lock them together. They created a seat, and it's up to the engineer how he discussed it with the architect and the builder. All right, just again, this was here, not the pile cap. The pile cap is this. That's where you got all the steel bars connected together between the pile cap and the, so again, remember the steps. Excavate a hole. If it was the CFA method, which is definitely used for large projects, deep basements, excavate the hole. While you excavate with the CFA, you're going to pour the concrete, submerge the steel with a decent lap, put your pile cap. Then next, we will start getting the trucks to excavate. See what they're doing here? They start excavating to the acceptable depth. And we will do what I showed you before. Next year, if this is something different, don't get confused. I will talk to you about it when I have time, maybe during the workshop. This part, it's nothing to do with what you're doing here. But if someone knows, let us know next week or Wednesday. Yeah, so here you can see in the picture how they're pouring the shotcrete walls over 2 steps. I did tell you the problem here and the challenge if it was missed, but this is correct. Obviously, they done the right work here. They have left it because they get it. I know this picture should come really before. So this is, they just placed the pile here. They didn't place the pile cap. So or maybe this was a different area with which they did not start here. They just put the piles. Yes, this is how they're gonna inject and put the nails, which is, we will talk about this next week. They just here in the process of say digging this hole. I told you there's a special equipment which will inject a cable and the concrete. Say this is really very specialized equipment which will excavate through the pile and 7 meters into the soil, then inject a cable, then inject concrete, then do the retentioning. We will talk about this next week. So I think here we started. Yeah, we do have some good pictures to talk to you. So I will go through those pictures maybe at the start of our workshop, and then we can continue our workshop. Now talk about assignment 2. Any question? So let's stop it here and let me stop the recording.